Welcome back, everyone, to today's Explainer. So if you've ever used a RAG system, Retrieval Augmented Generation, it's kind of like having a super fast software clerk fetching files from your digital cabinet. But what happens when that clerk just starts totally mixing up different departments? Well, today we're diving into how to fix broken AI search. We'll be looking at a tool called prismrag, and honestly, we're going to learn how to act like city planners to zone our knowledge base.
I mean, think about it. Why does your AI system mix up financial risk and growth? Or if you're in a hospital, why on earth is it mixing up strict medication guidelines with a random list of patient symptoms? It is incredibly frustrating, right? You ask for something specific, like, say, volatility in a risk model, and the AI hands back this beautifully written but completely wrong answer based on a marketing team's growth pitch. It sounds totally plausible, but it's pulling from the entirely wrong material.
And that brings us to the real villain of our story today, category bleed. This happens when your search retrieval just waltzes right across boundaries that you actually care about. And why does it do this? Well, a standard vector search only really knows that words are statistically nearby in your data. It sees glucose and diabetes and just assumes everything near it, whether that's strict insulin dosing or just a note about blurred vision, all belongs together. It literally doesn't know that these are entirely different operational categories that absolutely must stay separate. Okay, so here's our agenda for today's explainer. First, the category bleed problem. Second, introducing prism array mapping. Third, step 1, define core categories. Fourth, step 2, map specific words. Fifth, the map in action. And finally, real-world audit trails. Let's get right into it. Section 1, the category bleed problem, the chaos of the unmapped city. So think of your knowledge base like a sprawling city. Standard graph RAG essentially sends a robot out to draw a map based purely on where people happen to be walking. It's inferring relationships just from how often words happen to appear together in your documents. So imagine a bunch of people jaywalking across a busy highway. The robot sees that and thinks, oh, that must be an official crosswalk. The corpus itself is dictating the connections through totally accidental word co-occurrences. You just end up with a map of absolute chaos. And worse, it's practically impossible to explain why the AI chose a specific path to get to an answer. Moving on to Section 2. Introducing prismrag mapping. You supply the blueprint. Now look at the difference here. On the left, with standard GraphRag-G, the corpus is deciding what links to what. But check out the prismrag approach on the right. Your team decides what links to what. You aren't just sending that robot out blind anymore, you're actually handing it an official zoning map first. You tell it exactly which neighborhoods exist and which exact addresses belong in which district. This is a massive, game-changing inversion of control. It firmly puts human intent back in the driver's seat of your knowledge graph. So, how do we actually build this official zoning map? Well, it really boils down to a super straightforward step-by-step guide to setting up a custom mapping table. Step 1, you define your core categories. Think of these as the neighborhoods in our city. And step 2, you create specific word-to-category rules. Those are the specific street addresses. Today, we're really going to focus heavily on this setup because this custom mapping table is exactly how you stop category bleed dead in its tracks. All right, Section 3, Step 1, define core categories. Zoning the neighborhoods. Before you ingest even a single document into your system, you have to sit down and decide on your highest level buckets. We usually use short identifiers, or slugs, to represent these. So, for example, if you're a hospital, you might zone out your neighborhoods into medication, lab results, and symptoms. Or if you're working on a finance desk, your neighborhoods might be risk, growth, and contracts. You are essentially drawing the hard borders around the different logical partitions of your business. This first step, it's pure human work. It relies on your domain experts to encode their actual intent into the system. Section 4. Step 2. Map specific words. Assigning the addresses. Now we get to the really good stuff. This simple but incredibly powerful table is your Tier 1 rule mapping. You are literally hard-coding specific terms directly to your core categories. Take a look at that first row. The word volatility is permanently assigned to the risk category. This means when the AI sees the word volatility, it is physically forced to keep that chunk of text in the risk bucket, even if it happens to pop up in a document about growth. Insulin always stays in medication. Fatigue always stays in symptoms. You're encoding your human intent into hard rules, so the software executes it consistently, every single time. No exceptions. Let's see this come together. Section 5. The map in action, from rules to retrieval. So, What actually happens mechanically when we feed documents into a system governed by these strict new rules? Well, the magic happens during ingestion. Every chunk of text gets assigned dual vectors. On the left, you've got the semantic vector. This is your standard 768-dimensional mathematical representation of deep meaning. It knows what the text is about. But over on the right, we have prismrag's secret weapon, the personal vector. This is a 256-dimensional, category-grounded projection based entirely on those exact rules we just built. Having both is honestly like giving a document a highly nuanced meaning coordinate plus a strict, unbendable topic label. This dual system gives you that deep meaning while ruthlessly enforcing category discipline, so your risk chunks literally never bleed into your growth chunks. But wait. You might be wondering, what if a user asks a cross-domain question? Like a clinician might legitimately need to ask something that spans both medication and lab results. Well, that is where bridge vectors come into play. These are approved synthetic connectors between different category communities. So while our boundaries are super strict, we can still build deliberate, approved border crossings. You explicitly configure a link between, say, medication and lab_results so the system can answer a holistic question. But it does it without letting the whole category system collapse back into one messy blob. Okay, so when you finally ask a question, the graph search pipeline flows through these 4 specific steps. First up, community routing. The system looks at your query and basically asks, okay, which neighborhood are we in? Next, graph expansion. It walks the word graph using a breadth-first search, or BFS, exploring related concepts layer by layer, but strictly staying on the approved paths that you built. Third is semantic re-rank, where the candidate chunks are rescored so the absolute most precise meanings float right to the top. And finally, a direct fallback. That's just in case the graph walk finds nothing, ensuring you still get a graceful result instead of just an empty screen. Section 6. Real-world audit trails, the traceable future. Imagine seeing this output. This chunk was classified under Rule 47 in the medication category. Wow! Because you actually took the time to define core categories and map specific words, you don't have to just shrug your shoulders and guess why a document appeared in your search results. You have a fully verifiable audit trail. When compliance comes knocking and asks why a specific answer was generated, you don't point to a black box. You point directly to an explicit, auditable mapping rule that your own domain experts actually wrote. And this, right here, is exactly why this matters so much for highly regulated enterprises. In healthcare, you absolutely need clinical decision support without symptom bleed, because patient safety is quite literally on the line. In finance, research platforms demand strict risk isolation, so risk vocabulary doesn't accidentally drift into growth narratives. And in legal, you must have strict per-matter boundary compliance. For these teams, having different knowledge graphs based on exact, hard-coded rules isn't just a nice-to-have feature, it is mandatory infrastructure. So, as we wrap up this explainer, I'll leave you with a provocative thought. The absolute best AI systems out there don't just find text that sounds related, they find the right category of truth. So ask yourself, can your current AI system prove exactly why it retrieved an answer? Because if all it can do is tell you that a statistical embedding was quote-unquote close enough, well, it might just be time to start drawing your own map. Thanks for joining me today, and as always, keep learning out there.